Okay, good afternoon, everyone. Welcome again to the second edition of the NVO Open Science in Practice webinar series. Thank you for joining us today. My name is Maria Cruz. I'm an open science policy advisor at NVO, the Dutch Research Council. I'll be your host today. I'm joined here by my colleague, Julian Larocque, is our Zoom co-host. And somewhere among the audience is also my colleague Hans de Jonge, who's also part of this webinar series. This is the second edition, as I said, of the NVO Open Science in Practice webinar series. In this webinar series, we highlight the projects awarded an Open Science Fund grant. And today we will highlight two projects that develop open tools for data enrichment and visualization. We will have two presentations today and three speakers. I didn't update the slide, but so we'll have, actually before I introduce the speakers and the presentations, and while you're all still here, I'm going to announce actually the next webinar in the series, which will be on fair metrics for fair software. Will be on a Thursday, as always, 2nd of June at 3 p.m. And we'll have Anna-Lena Lamprecht from Utrecht University. She will be talking about her project titled Fair Metrics for Fair Software. I think Julian will add the link to the chat. I'm not sure, I think registrations are open already, but feel free to register whenever if you're interested. So let's continue. Let's get back to today's topic and speakers. Very exciting topic today. We will start with a presentation by Jill Hilditch and Time Lanyao. Yet Waren could not be here today. They are both archaeologists at the University of Amsterdam, and they will present their project 3D Workspace, an open science interactive tool for 3D datasets. Our second speaker is Rogier Kievit from Radboud University. He's a neuroscientist at the Donders Institute for Brain, Cognition and Behavior, and he'll present his project Raincloud Plot 2.0, a robust and transparent data visualization tool. I'm really excited to have Jill, Time, and Rogier here today because beyond being leaders in their respective disciplines, they are leading the way when it comes to advancing open science practices in their fields and beyond. We're delighted to have you here today. So I'm gonna pass the virtual floor. I'm gonna stop share. And I'm gonna pass the virtual floor to Jill and Time. Jill and Time, the floor is yours.
Okay, thank you, Maria. And thank you very much for the invitation to be able to talk about our 3D Workspace project. We were all thrilled to get the money from NVO to start working on it and build it into an open science platform for our data sets. And so, yeah, Jutta is unfortunately ill today. He sends his apologies, folks, but yes, he'll be back with us soon, shortly. Okay. Can everybody see our presentation screen?
Oh, sorry.
Oh, there we are, okay. A brief flash through from finish to start. There we go. So, as you can see from the range of icons along the bottom, this is quite a large team that we're working with. And the reason for that is it's quite a complex thing that we're trying to do. If I start off by showing you a picture of our team, here we all are. We have Jutta and Time, who are based in the 4D research lab at the Faculty of Humanities at the University of Amsterdam. And then there's me and my colleague Luce, who are taking part on the Tracing the Potter's Wheel project, which is an NVO VD project, of which I am the PI and Luce is the PhD student. And that's based in the Amsterdam Center for Ancient Studies and Archaeology at UvA. And we're also working with a technical development team based at Create, an e-humanities perspective on digital Amsterdam in the media studies department, also at the University of Amsterdam. And we're also very lucky to be working with Hugo Herdeman, who's an assistant professor at the Open Universiteit Nederland, who is going to be taking the lead in our testing and our evaluation of our 3D platform. So I think it's really important to start off with a sense about how this 3D workspace idea came about. And it's very much a story about the bottom up. As I mentioned, and as Maria has mentioned, we are predominantly archaeologists, and we use a very broad variation or range of 3D models in our work in archaeology. On the Tracing the Potter's Wheel project, we are primarily using what we would call object 3D models. And you can kind of get a sense of this on the image on the left of your screen. We are trying to look at processes or production forming methods for ceramic vessels to be able to identify those methods, such as the use of the potter's wheel and how it was used, and trace it through archaeological assemblages regionally to look at transmission of technical knowledge. And we're building up a data set that's based in high resolution photography, 3D models of experimentally reproduced pots that allow us to identify specific traces in connection with specific techniques of production, and to use a blend of those different media to help ourselves and others recognize those forming traces in their own material data sets. And this is the opposite end of the 3D model from the other case study, which I'll let Time say a little bit about.
Yeah, so the other end of archaeological objects that archaeologists are generally studying and analyzing is entire landscapes. And at the 4D Research Lab, we do a lot of remote sensing. So that's basically studying the surface of the Earth from sensors that are higher up in the sky, like satellite data from airplanes, but also drone remote sensing. So we generate a lot of different types of data, and for an important part, this is also 3D data of archaeological landscapes. And one of the things that we do with this, we generally work in international teams of different specialists studying archaeological site or an archaeological landscape. So what we really need and what we're basically lacking is an easy, convenient way to share these models with the different specialists, with the different like people that are working, collaborating in the same team, being able to quickly discuss, analyze, and comment on this on 3D models that are generated by drone data without having any specialist knowledge of like how to load and work with 3D models. So that is something that we really wanted. And so together with Jill in discussion about what we wanted, how we want to use our 3D data in collaboration with others, but also as teaching, we came up with this idea of developing 3D workspace.
Yeah, this kind of platform is sort of kind of out there, but we didn't really find something that fitted our needs, because even though we work with object models and landscape models, so effectively different scales, we couldn't really find a 3D viewer or a tool that would allow us to share our data, not only with specialists, but also to allow greater accessibility of our data with non-specialists. So what we wanted to do was to collaborate internationally, to allow our data sets to be used as educational or training tools, and to provide really this engagement with archaeological data. And I think Maria put it really nicely. She said, you're not just talking about getting data, you're also talking about playing with it. And that's really what archaeologists do quite a lot, is play with our data. We really wanted to feed into a growing movement of promoting two-directional knowledge transfer. We're often accused of not communicating our work sufficiently to various stakeholders, be that the general public or to students or to other specialists. And this is partly due to what we would call the complexity of our traditional heritage data sets, where some degree of training or specialization is almost a prerequisite to being able to play with that data. So one way we thought to do this is to create a 3D model viewer that automatically provides structured guidance and training to allow non-specialists to participate with specialists, as well as to create an environment where people can annotate and curate their own collections of models for a particular purpose and to help others build narratives for these heritage data sets. So why 3D Workspace? We wanted to improve accessibility, and there is nothing like a global pandemic for reminding specialists that we have problems accessing our own data sets on occasion. So understanding that non-specialists face even greater barriers for accessing these types of heritage data sets is really important. And we also wanted to facilitate the interaction. So not just for people to see a bunch of models on a screen, but to really be able to go in, explore, annotate, and create those narratives with their own research interests and their own backgrounds in mind. So even though it started off as a concept that was very much rooted in a heritage environment, we realized quite quickly that these types of tools and this sort of platform would be much more broadly applicable outside of heritage as well for others working with 3D data sets. So how are we going to do it? Well, this is the way we wrote about it in our proposal. So fingers crossed it all goes to plan. We are going to adapt an open source Voyager 3D digital museum curation tool suite, which is already up and running courtesy of the fantastic team at the Smithsonian Institute in the US. We are also going to embed structured guidance and training to gain competence, to build skills for non-specialists in how to work with and how to interpret complex 3D data sets. We're going to create annotated personal 3D collections, or allow others to do that can then be tailored to their own specific learning goals or interests, be they students or members of the general public or research specialists. And we really hope that in doing this, we're going to open up new avenues for knowledge publication and broader narratives for interpretations coming out of these 3D data sets. So just to give you a really quick peek into how cool this Smithsonian Voyager 3D viewer is, not only do they have fighting dinosaurs, they also have Neil Armstrong's spacesuit and all sorts of other cool things on the website. So we went in and we discovered that this tool, far more than something like Sketchfab or 3D Hop, was very close to what we wanted to achieve because it had been designed by heritage professionals in mind and for a non-specialist audience. So there's absolutely no point in starting from scratch. And we contacted the team at the Smithsonian and they were really happy to chat through and talk about the possibilities for building upon their work, which is available in GitHub, an open source platform. And so that's where we chose to start. So there are a number of 3D data sets already up online that are accessible. I mean, in the bottom left, you see my project's database of experimentally reproduced wheel-coiled and wheel-thrown pots. In the top right, you have dynamic collections of the Dark Lab of the University of Lund in Sweden. And this has really come online in the last few months with a lot of their 3D models from objects that they have curated on there. And also in the bottom right, we have the 4D Research Lab with their own curated collections of models up on Sketchfab. And so whilst these are all openly available and open data, What they don't provide is a kind of an open tool for the models, the reuse of the individual models. You can pinch them, you can create a collection, you can talk about them, but it doesn't feed into the wider narrative for that model. So what we wanted to do was to go the next step, basically. So what I have here is a very brief little video, which is a walkthrough of an excavation of Jamestown, which the Smithsonian are highlighting with the team there, which shows which aspects of this Voyager we're most interested in. So just like Sketchfab, you have an ability to annotate, to create points of interest. But what this platform allows you to do is, in more detail, to think about how you elaborate upon those points. So you can write articles, and you can also embed lots of other web links, as well as different types of media to help talk about and visualize these points that you're annotating on your 3D model. But the bit that really interested us was what they call a scene tour, an interactive tour, which provides structured guidance and narrative through a 3D model. So it allows you to build that knowledge over time, as well as to give you all the enrichment of the data and increased visualization potential on top of that 3D model. And so we thought that was a really nice, suitable platform that we could go in and tinker with and tweak for our own purposes. So yes, in this platform, you can annotate and you can add information to a 3D model, but you don't actually modify the model itself. That's something that's only really still possible for the creators of the content and not for the end users. And so we want to go that next step and think about the end user. This is a very brief illustration of this structured guidance or this learning pathway that we'd like to provide to give specialist knowledge and accessibility to non-specialists to be able to deal with these complex data sets. So this is an imprint of an experimentally reproduced pot, which has been 3D scanned and put onto the Tracing the Potter's Wheel Sketchfab page. And we have annotated specific features that help us think about how we identify wheel coiling as a production technique in experimental vessels. So it can be quite complex, but you have the accessibility of manipulating and rotating the model, clicking on, zooming in, adjusting your light source. By creating a number of these structured learning pathways, we really hope to provide both up-and-coming specialists, such as students in an educational setting, as well as non-specialists in non-educational settings, the ability to kind of get on board with this complex data set, to understand why we look at ceramic forming traces, how we identify them, and where the ambiguities in that diagnostic identification process lie. And in knowing all of those things, people can bring different perspectives and different things across multiple models and make curated collections of their own to highlight some of these technological traces and decisions. So this is a very brief example of what we hope a learning pathway in this platform is going to look like.
Yeah. So how is this ultimately going to look like? So we are just out of the designing phase, and we just started the developing phase. And as an illustration of what we envision, I'm going to talk you through the preliminary designs of these applications that we have so far. So the application will run on a website like this, and this is a mock-up that we created to share with the team to get all the features, the desired features in place. And we envision this as a website which allows you to access 3 levels, you can say, of these models. So we allow users to browse the models, which basically gives you access to the database or a list of all the models that can be searched for. And also these models can be added to collections. So users, registered and logged in users, such as students, tutors, researchers, can create their own collections with these models. Collections, again, can be searched for. It will be sort of a database of collections. And when you're going into these collections, and basically learning pathways are a type of collection. So collection and learning pathways are basically the same thing. Yeah, you get into a view where you see these models that belong to this collection. And how we envision this to work is that users can use these models for instance, comparative analysis. So collections are made for a type of object or a type of archaeological features. And and one of the important things is that these collections can also be made by groups, collaborative efforts. Also enabling discussion on this platform, on this collection. So users will be able to add notes and add responses to these notes, allowing sort of online archaeological research to happen based on these models. And then what Jill already talked about, learning pathways. Learning pathways are a type of collection that we envision as pre-curated narratives basically linear narratives with a certain topic. So they want to teach a student something specifically about, for instance, pottery, coiling techniques, or certain landscape analysis. And these texts that are created for learning pathways basically link to all the models in the collection. So hyperlinking to specific views or specific traces and to specific areas of 3D models. So you're reading this text and the 3D models illustrated, and the text also illustrates the 3D models, and they're on the same level basically. So then these things that you see here are all like active 3D viewers. I mean, this is a mock-up, so I cannot show you that they can really turn around and be studied and zoomed out and that kind of thing, but they will be active 3D viewers. But you can also go one level deeper into the model view. So you're clicking on one of these models and you get into another view. And this is basically our modified version of the Smithsonian Voyager with all the added functionality to it. So now users, rather than only curators of the museum, but all users that are logged in and registered can create annotations, add their own sets of annotation related to their own analysis or their own narrative. And edit the text and use other media to explain or to illustrate what their narrative. And again, also allowing others to respond on this, allowing this to be used as a discussion and analysis and teaching platform in this way. So let's go back to the presentation. So we're working now on creating a working prototype of what I've just talked about. And we're hoping to have this finished somewhere in early summer. Then a little bit about the outputs. What will we ultimately like alongside this application, this website that we're creating, we will deliver. So all the source code will be, of course, online available as open source data on GitHub for our modified version of the Voyager viewer. We will be creating 3D workspace collections with 3D datasets showcasing the possibilities for education and research outcomes. So we will already be making some examples of how can you use this, illustrate it, and stimulate others to start using this in this way. another thing I haven't talked about yet is that all the data, so we will use Figshare as our data storage platform. So all the 3D models, all the 3D data will be stored there, and that allows for sustainable, persistent storage and sharing of the 3D models and the annotation data sets. And then we will also be creating training materials for 3D data visualization. So they will be created as learning pathways, but also workflow tutorials in video series and this kind of thing. So again, stimulating and teaching others how to use this platform. And then we will be also publishing in reports our entire workflow, how we create this app, and also intend to write 2 peer-reviewed papers about the project. So with that, we have come to the conclusion of our presentation.
Indeed. Thank you very much, Jill and Time. Perhaps you could stop sharing. It's a fascinating project indeed. I was just when I was speaking with Jill just before we opened the room. Indeed, when we in the open data field and fair data, when we talk about open access to data, it's really about just getting the data, and this project is really adding a different dimension, really making it accessible in different ways. Are there any questions? Oh, there's a question. Thank you, Rogier. Will it become possible, easy, encouraged to 3D print the objects, either commercially or downloading a printable mesh file? I'll copy the question to the chat, because maybe Jill and Time, you're probably not on Slido, so that's the question.
I mean, in theory, yes, because all of the models that we are introducing into the 3D workspace will be completely open access. The copyright issues will allow people to take them and modify them and do whatever they wish. So maybe it's about the downloads that are available of those models inside the platform. So we haven't talked about that explicitly, what types of files, but it's definitely there as a possibility, yes.
Yeah, technically it would be very easily implemented. And I think it's something that we seriously should consider to make that like direct download links as well. Yeah,
because we've been I did these outreach talks with brains, and we can have pictures, but we can also 3D print, for instance, my own brain, and then hand it to someone, and there's something kind of fundamentally different about someone picking it up. And generating the mesh is a bit of a hassle, too much for the common user. But if, say, a teacher in a school was like, oh, let's download or print some pots for $20 a piece, then maybe.
Well, to give a shout out to Luce Opkenhafen, who works on the TPW and on this project, she has already generated a teaching collection of 3D prints of traces, which she's used the ability to zoom into the model, print it out at a much larger scale. So you can actually see the details in the 3D prints and allow that really important tactile sensation of being able to feel something and then translate it to another object in a hand specimen. So I'm picking it up. So yeah, Luce is definitely following that as a really worthwhile educational and communication tool, the combination of the modeling and the printing. So yeah. I'm not sure how that would work for drone landscapes, though. That might, but for an object,
yeah, it would be interesting. But I'm not sure if there's any big analytical advantage of that. But yeah,
but for the objects,
yeah, for the object, definitely, and it is frequently done as well in archaeology. So yeah.
We have a second question on Slido. How many models have been annotated so far? Would the data allow to automate of the annotation process at some point, e.g., for example, with deep learning?
Ooh, yes. Once upon a time, at the beginning of our Tracing the Potter's Wheel project, we thought about generating algorithms for automatic trace recognition. We didn't end up going down that route, so I can't answer anything about specific applications of deep learning. But I think the idea about the annotations is there is value in having the opinions of the people being able to work on and annotate the models about what is and what is not visible. So generating that knowledge from a range of different visual perspectives rather than simply training AI or deep learning to be able to recognize it for you. So that's one aspect, but I think that's not what we're working for in terms of the 3D Workspace platform.
And as regards to the first part of the question, how many models have we annotated so far? Well, none yet. We're still creating first the platform, and after, so that will be finished early summer. And after that, we will start adding content, including the annotations.
Yeah, we're both going to draw from the Tracing the Potter's Wheel and the 4D Research Lab Sketchfab collections and models. We'll use those as a starting point for feeding into the 3D Workspace.
There are no more questions in Slido. Are there any other questions people would like to ask before we move to the next presentation? It's a small group, so if you'd like, you can also add the questions on the chat. We are a small group today. Might be easier. If not, I'm not seeing, I don't see any questions appear, either the chat or Slido. So I think we're gonna go to the next presentation if you're ready, Roger.
Yes, let me share.
Thank you very much, Jill. And
yeah, that was
Thank you.
great. I like the playing around with models. That's a great idea. Let's see. Does this work? Can you see everything?
Yeah.
Fantastic.
Yeah.
So thank you very much for attending. My name is Roger Kiewit, and I'll be talking about our Raincloud Plots project. So for a tiny bit of background, I'm the PI of the Lifespan Cognitive Dynamics Lab in Nijmegen at the Donders Institute and the Radboud UMC, where all of us, especially including Jordi van Lange over on the far right, who is heavily involved in the project today and is also attending, we work on studying how and why cognitive abilities change across the lifespan. But that's not what you came for, so I won't talk about it too much. So I'll give you some background on data visualization and open science. I'll talk through what Raincloud plots are, the history and the development of our project, and then our future plans with the NVO Open Science Fund. So my first argument would be probably don't need that much convincing that data visualization is arguably the single most powerful way we can communicate messages broadly. Just to give some kind of lovely historical examples, there's this famous figure by John Snow in 1854. And there was a cholera outbreak in London, and the prevailing hypothesis was that a miasma or an air was the cause of this cholera outbreak. And he visualized the number of cases on a map, and from that it was quite clear that it was actually most likely the water pump, because the nearer families lived near the water pump, the more likely the cholera cases were. And he was right, and they closed down the pump and immediately essentially ended the cholera outbreak. Another example is by Florence Nightingale, a famous nurse who made these rose plots where she showed the cause of death. So there's lots of calls for better armament for the soldiers, and actually she showed that the largest number of casualties were preventable diseases, and actually the deaths in combat in the kind of red and black were far smaller parts. In other words, there were far more gains in terms of mortalities to be had by preventing those diseases than by preventing wounds in battle. And one of my favorite citizen science, open science projects from the 19th century, you used to have to pay for tide plots in the UK, these kind of maps of the tides. And they were commercial property, and William Whewell decided he would have none of that. So he got thousands of people across the UK to record the tide time of day, several times a day for several weeks, and then essentially collated all that data and made these tide plots available publicly for free, and immediately put out of business the people selling them, which I thought was a wonderful citizen science project well before the term was known as we do now. Of course, there are also more up-to-date data visualizations, including some we would rather forget, including kind of the corona statistics. I don't know if any of you follow these kind of people on Twitter who've done a really good job creating these pipelines to turn these incomprehensible tables of numbers into rather comprehensible projections, models, and incidence rates for the corona pandemic. There are a few data visualizations more compelling about climate change than these kind of quite famous plots like this. And also historical good news can be shown quite compellingly. These are, for instance, the data for child mortality across history, which suggests that as bad as things are and can be in the world, there are also some rays of hope. In other words, data visualization can do a better job than any section you may write at conveying a message clearly. But there are also a lot of bad graphs, and by which I mean very, very bad graphs. And I will gratuitously abuse this opportunity to show you some of my favorites. There are plots that have too much information, unless this is how you want to learn about the healthcare system in the US. There's this incomprehensible Six Sigma innovation thing where I'm still not quite sure whether I should rotate it 90 degrees or 180, or preferably turn it around facing the other way. And this tells me something about the American diet, but I'm not quite sure what, and I never want to see it again. Now that's too much information. There's also too little information. These are two actual published plots. The one on the left tells you nothing you need to know. And there's someone clearly annoyed by the amount of information in that plot, and they decide to go with this, which is also a published manuscript. Undoubtedly competent scientist, but arguably less competent at data visualization. There is the ugly. This is a pie chart of something, kind of 50 shades of gray is actually an underestimate, but these are all countries. Very useful, very insightful. There's the default SPSS histogram, which in addition to the number of significant digits, that is almost 10, I think. The default they went with beige. Why we pay for this, I have no idea. Don't. And this is, yeah, I can look at this all day. This should be in a museum. This is the Excel default if you use many different options. Lovely. And then there's the extra category that are downright confusing. So I'll give you some time to try to process the bicycle of education. So you might find yourself on the teacher seat or on the multiple student seats or on the teacher wheel. There's a lot going on here. It is data visualization of some kind, but I'm not quite sure what. Right. So our goal is to move beyond this and to improve everyday data visualization. So obviously there are a lot of problems with the plots I just showed you, but there are arguably also problems that are a bit more mundane. So our case with the Raincloud plots is that data visualization should show the data, not hide it. There's a famous Kickstarter project called bar plots, who made a compelling case that these innocuous bar plots, that essentially there are very few occasions where they're the right option. Why is that? Well, this may be the bar plot of your data, but if you look, for instance, at box plots, then suddenly the data looks quite different. So remember, this is the same data. And if you look at a histogram, then suddenly the differences between the groups are quite stark and striking. Yet we continue to publish bar plots like the one on the left that might obscure patterns we need to know about the distribution, about the parametric assumptions, et cetera, et cetera. In other words, this might count as a data visualization, but in many ways it's hiding more than it is showing. So our goal was to create a single plot that has all of the various benefits of these plots without hiding any of the data. So what we came up with were so-called Raincloud plots, and they look a bit like this, and I'll walk you through their elements just now. So they kind of move beyond the bar plots in actually showing you the data. So what is a Raincloud plot? It's a plot that visualizes the raw data in terms of data points, the probability density, the summary statistics such as the median, mean, and the confidence interval in a way that looks nice. In other words, you have all these benefits of these summary statistics. You have the benefits of seeing the actual raw data points, as well as the overall density plots. So we think they have a few of the drawbacks of plots and many benefits. So and I'll walk you through a little bit of the history because I think it's a nice example of open science and using modern tools to do collaborative projects. So originally my colleague in Aarhus, Micah Allen, was playing around with these and was increasingly happy, and I was helping him at that time, and now he's highly competent to learn R. And I suggested that data visualization is one of the many reasons to use R. And actually this is one of the first plots, and then for the historical record, John Royser suggested if you rotate them, you can call them Raincloud plots. So that was the day Raincloud plots were born. So Micah then created a nice blog post on his website, and I was also working on kind of a tutorial, and I decided to use them in a paper we published that year to visualize data for a little over 100,000 people in Biobank. So I think that was a way to show the summary of the data, but also the kind of the sheer amount of data in a way that I think we would miss out a lot on if we just use bar plots. Now, interestingly, when Mike originally posted that, I approached him and kind of tried to develop a how-to guide for people in my lab. Other people like Davide Poggiali, who was more of a Python user, suggested, well, I'm going to try to make it in Python. And Tom Rice-Marshall recreated it in MATLAB. And remember, these are all people who didn't necessarily know each other, definitely not in person. So what that essentially then led to was from tweets to papers. So Micah Allen, Kirsty Whitaker, who's an expert on Jupyter notebooks, Davide Poggiali on Python. I worked on the R tutorials, and Tom on MATLAB. The first instance of the kind of Raincloud Plots project was essentially done all in Twitter DM, a group channel where we just chatted and we created the GitHub page and we kind of worked together. This is before Zoom functioned as well as it does now. So that's essentially the way we communicated. So we then ended up writing a paper that was published in Welcome Open Research, which is quite a nice format where people who have some form of Wacom funding can essentially publish for free there, so which we thought we would support. So this paper, we describe why we think Raincloud plots are a nice alternative and gave people a walkthrough tutorial in 3 languages, R, Python, and MATLAB. So in R, for instance, one of the main things we did was create these annotated code bases and also that simulated some data. In other words, people can literally copy paste the code into their terminal in R and create these plots. And we wanted to make it relatively easy and give people some examples of slightly different designs, slightly different versions. So people could design, hey, I want something like that in my paper. Which code should I use and how do I change and modify it? We were able to make them slightly more complicated, have these kind of group and nested designs. We recreated something very similar in Python. You can choose, for instance, how smooth you want it, whether you want outliers to be annotated differently. You can have repeated measure designs where people are measured on more than one occasion or in more than one group, and you can link them. And then MATLAB, slightly less open source, but used very commonly in engineering as well as neuroscience. So we made a similar package there. And then we started work on the revision, and then Jordi van Lange, who's present with us here today, posted on Twitter that, inspired by some of the work we did, was he did what we wanted to do but didn't have the time or the capacity to do, which turned it into a rather nice precursor of a package. So he put it all on GitHub and made some really nice, I think, default plots, so much so that we approached him and essentially invited him on board. So he helped us create a Raincloud Plots proper standalone R package and stickers, even more important, of course, than a package. So people can kind of visualize these, and I think with rather nice defaults, and they work especially well for the kind of simple, relatively simple 1x1 and 2x2 repeated measure designs. So we kind of got that finished with Jordi's help in time for the revision. So what's the impact of Raincloud plots so far? It's either good or depressing that this will likely be one of the more impactful things I do in my career. But if you count everything up, we've reached about 4 million people on Twitter, depending on how you count exactly. I think we're about to reach probably realistically 1,000 citations this year, and this was published in 2019. It's used in psychology, neuroscience, chemistry, meteorology, philosophy, and beyond. So it's quite interesting to see who use it to create their data. The paper has been viewed almost 100,000 times, and people are handing out GitHub stars with reckless abandon. And most importantly, we made it to the front page of Reddit, which is, of course, the thing we all strive for as scientists. So it's very nice to see this kind of collaborative project between people who haven't even met the majority of the people in the Twitter DM. So it's just like, let's make something that we would use and that we think other people might use. That it caught on, and so many people were so enthusiastic about it and ran with it, and many expanded beyond what we thought you could do with it. So some kind of qualitative analysis on why I think it succeeded. Well, firstly, I think they look good. Secondly, I think in the paper we try to make a point of that it's a tool, not a discovery or invention. So there's lots of people who've made very nice kind of other better alternatives to bar plots. There are pirate plots and bee swarms and lots of lovely names, and we made sure to kind of note that lots of people have other clever kind of improvements over bar plots. In fact, I dug up one person on Twitter reached out and I dug up what's probably the earliest precursor, not necessarily of a Raincloud plot, but something very close, which is in the bottom left here. And the appendix of the paper has a dot matrix printer instructions on how to make these. Probably not going to be reused that much, but it was nice to do kind of a historical dig of people who clearly had the kind of similar idea well before us. And I think people like them because they're almost always better than the default alternative, although there are some exceptions. I think they make it relatively easy to do kind of maximize the statistical information you can see at a glance without compromising on what the data actually is. So it looks nice and it tells you most of the things you want to know about your raw data and the distribution. And we tried our very best to make it accessible in 3 different languages that are commonly used. And I think the tutorials start simple. So I read a lot of kind of stats tutorials, and sometimes they start with what the author thinks is a simple example, but actually isn't. So we try to basically also start with some example data so people could really build it up, and almost anyone, even people who are less familiar with coding, were able to kind of hit the ground running. And we had lots of kind of Twitter threads on people who just started one afternoon and a few hours later had all the figures they wanted. So where do we go from here? Well, you already noted the Open Science Fund. So we've been working a bit and thinking about how to expand it. And then we thought, well, this would be a nice way to do it. Firstly, let me reiterate that this is a fantastic initiative. There's lots of things to like about it. I especially like, so lots of the open science workshops and discussions, a question that often comes up is essentially asking more senior people, well, what are the benefits of doing open science? And often the case is that you do it because you think it's important or valuable. And I think this is one of the first formalized instances where I've seen open science track record explicitly be assessed as part of the likelihood of the grant or the fund being awarded. So I thought that was a nice touch, making explicit. It's not just about your future plans, but also what did you do maybe in the years where it was less explicitly rewarded. So the plan is, Jordi is working on it as of 2 weeks ago, 1 day a week, and then we will soon hire a second person to work on this project. You might ask, what is our plan? So our first work package will be to take the kind of Raincloud plots package and to improve and extend it and to make it more flexible for more complex data design. So what if you have 10 waves of data, can you still make a nice default where you don't have to manually constrain the format of the data? So we're going to extend and expand the R package. We're going to do so in part for things we think it should have, but also ask people what they think the package should have. So we're going to get some community engagement and user feedback, which we may regret or we may not, but we'll ask people, what would you like to see in a new version of the package? And then we'll submit it to CRAN. We'll also create a Shiny app. And for those of you less familiar, it's a platform in R where essentially it's an interactive online version of your code. So what you can do then is people can take their raw data file, their CSV, and as long as it's organized in a certain kind of comprehensible way, you can essentially drag and drop your data and it will generate Raincloud plots, which people can then download as SVG or whatever format they like, which hopefully, or our goal is at least, remove some of the barriers for people who may be slightly wary of learning to code. They can then immediately get Raincloud plots, and then hopefully they'll also see that the code that it generates is actually not that scary at all, and that they undoubtedly can do it if they spend maybe an hour or two familiarizing themselves with it. So those are the things we're starting on for work package 1. Work package 2 is to do some outreach and education. So we're going to organize some workshops very much like this, but possibly ideally also in hybrid format, where we'll do some step-by-step tutorials. So essentially people will be able to join, and we'll have breakout rooms depending on the preferred software package to use, R, Python, MATLAB. We have some inkling to also translate it to Julia, which is kind of a open source version of MATLAB, but that's very much in the if we have time to spare. So the provisional dates, note all of them in your diaries, of course, will be these. So you can join along, and the target time is 2 o'clock so that people in the US can wake up very early. People in Australia can stay up very late and all join us to create some Raincloud plots. Crucially, you will get free stickers if you attend the hybrid event. So you already created these wonderful stickers. And I recently bought a black gazelle in Nijmegen, and I had not quite calculated how hard it is to find a black secondhand Gazelle bike in Nijmegen. So I plastered the whole bike in Raincloud Plot stickers, and now I can easily find it. So if that's not a good reason to join our Raincloud Plots workshop, then I don't know what is. Finally, the third work package is to integrate Raincloud Plots further into Jasp. And Jasp is essentially an ERC-funded free equivalent for SPSS, which has the added benefit of also allowing you to do Bayesian inference. So essentially all your standard tests that you're used to doing in SPSS, like t-tests or ANOVAs or whatever they may be, you can now do them in a Bayesian fashion. It looks very nice and it's free, unlike SPSS, which if you kind of, depending on where you work, people are paying thousands and thousands of euros for you to use SPSS. At my former institute, I think with 100 people, I think we paid £100,000 a year for SPSS, which for a Bayes histogram is more than I think we should be paying for it. So this Jasp package, which I have done nothing to, but I think is a very commendable open science project to use essentially all over the world and has about 30,000 monthly downloads. And they've implemented a simple version of Raincloud Plots, and we're going to help them expand that and extend it so that people who are also making the transition from SPSS to a more open source version of SPSS will be able to use Raincloud Plots. And ideally, we hope that this will be a gateway to get them to learn to code. So if they can get their analyses up and running with this way and actually see what the code looks like, then I think the vast majority of people, even those who think themselves as less of kind of coders or programmers, will be able to make that jump. So the timeline is more administrative, but that's how we hope to achieve our 3 work packages. Ask us again in March of next year. And on that note, I'd like to thank first and foremost the MWO for this wonderful initiative and the invitation today. And I'm happy to take any questions. Thank you.
Thank you so much, Rogier. It's, yeah, again, a fascinating project. I love how the project itself breathes open science throughout. It's not in all fronts, really, very collaborative. I have some questions, but we have questions in Slido, so I'll look at the questions from the audience. Most voted question, great work. Are you planning to have an export R code in your Shiny app?
Maybe Jordi also wants to jump in, but that's definitely the plan, I would say.
May have to unmute him. Oh yeah.
Yes, I'm sorry, I'm unmuted. I can't start the video, but I hope you can hear me. Yes, that's definitely what we're planning for. We still have to design how we're going to do it, but that's definitely on our agenda. So yes.
Thank you. The next question is, any interests already from commercial parties to implement Raincloud Plots? So any commercial interest? Are you going to start a business?
No, I mean, it would go against the whole spirit of it. I mean, I wouldn't really know how you would copyright it sensibly. And I regularly advocate for people abandoning the kind of closed version of their software. So no. Although anyone who wants to sell them or create a package to sell them, more luck to you. If you can make a lot of money with it, congratulations.
We have another question. Having this on CRAN would be great. Are these already part of Seaborn, or can they be made part of Seaborn?
To recall, so I think the package is called Le Petit Prince, I think. I think it's made in Seaborn. I don't know if it's been natively exported into Seaborn itself. I don't know for sure. A bit like with R, we did consider, do we want to turn it into a pull request into ggplot, for instance, so to make it be, so ggplot is kind of a really popular data visualization framework in R. So you could imagine us writing to them saying, well, you could just make it a version of their module. But we ended up kind of doing it in this way because then it would also be easier to translate across panels. But I will ask Davide, who's the kind of, who leads the package in Python.
And then we have, it's more of a comment, I think, rather than a question.
Yeah.
The possibility of selecting components would be nice. For example, only the box plot or density parts.
I think that's a really good idea. Yeah. So I don't even think we considered it in that way, rather to allow Shiny to just create a default plot. But I think that's a really good idea because we could allow people to see the improvement, or what we would consider the improvement over bar plots. So I think that's a nice idea that we'll certainly consider in the Shiny app. So because there are some cases like frequencies, etc., where a bar plot might actually make sense, and ultimately we want to leave it up to people which one they prefer. So I think that's a good suggestion.
Any more questions? I'm not seeing any more on Slido or in the chat. Are there any more questions? If not, I may take the discussion somewhere else, less technical, because you were talking how you said it's might be depressing that this might be, I think you said it in jest, but one of the things that has your work with most impact. But I mean, very seriously, yeah, it's really incredibly impressive. And do you think there's enough recognition and rewards for when researchers do something like this, that it's not it's maybe not what is expected from you, right? To develop this sort of visualization tool. Should there be more recognition and for this type of activities? Do you feel there's enough recognition?
No, I mean, we didn't do it to then ultimately kind of get recognition, if you will. We wanted to make something that people would use. But I think in general, open science initiatives aren't really recognized to the degree that arguably they should. I mean, there's some famous cases in neuroscience where people who created these pipelines that literally everyone in the world doing imaging use then failed to get a faculty job and now work at Google, because like they make these things that literally get cited thousands of times and everyone uses to do quality assurance on their imaging data. And then they apply for kind of faculty posts in cities where they would like to live or not have to move with their family. And then they were like, well, where's your paper in Nature or something kind of that has classical metrics? And then they don't get a faculty job. And they're like, okay, bye. So no, I don't think it is. There's a tool I use literally every day, written by someone in Ghent. It's a package to do a particular type of modeling, and he essentially has to convince his dean to recognize that this thing which has been cited 15,000 times, this package, that is not just his hobby in the kind of night times. He has to like essentially ask for permission to spend time on it, and it's one of the most impactful things you can do. I mean, in my job ads, I've started to, over the last kind of 8 years, I've always added a section like, tell me what you've done in open science, not the kind of future what do you want to do, because I think there's far more value in what people already actually did. So if you ask me, that should be a default question in kind of job interviews, and you can then decide how strongly to value it. And I think it should also be in grants, and I like the fact that it was so explicit here. But for me, it's been a bit, sorry to ramble on, last quick comment. For instance, almost every big project will say we'll share the data. Now, for a long time, every project also said, we'll make our papers open access. And in the UK, for instance, where I was, if you didn't make your papers open access, they would literally not give you the rest of the money of the grant. So you can bet people actually made their papers open access. However, if you don't share your data, if you say data will be shared upon request, which means I'm not going to share it, then nothing happens. So I think there needs to be a tighter link between promises about data sharing and promises about open science, and then actually the funders may be taking some time out of their resources to see, well, did people actually make the data available in the time frame they said they would? So that's my endless monologue, sorry.
Oh no, it's does anybody in the audience would like to chime in here through the chat, or Jill and Time? I don't know if you have any reflections on this topic you'd like to share. Don't have to.
Yeah, no, I feel your pain there about colleagues who struggle to have these outputs fairly assessed and sort of weighed up against their academic profiles. It's almost as if it's felt not to be an important part of academia. But to be honest, this two-way street, and this communication and this accessibility is fundamentally part of our responsibilities to communicate our research and our response. And yes, there needs to be much more, I think, from funding bodies and universities to recognize contributions in that way. So I totally agree with you, Rokia, yeah.
Anybody? Oh, there's some comments actually on the, yeah, it's comments on the chat about that PLOS. I could comment as a reviewer about that data not being available. And recently I requested data upon request and got them within a week. So it seems to be getting better. So yeah, I'm wondering, in a way, it's the responsibility of the funder, but these comments make it seem it's also maybe a responsibility of the community to when publishing papers, when reviewing, to ask for these things. Would you agree with that? That it's both the...
Yeah, but I agree it's not only the funder, but I think in practice, people just don't respond back. And it's also kind of, there are bad reasons for not sharing your data, including I don't want to, or but there are also sensible reasons to not share your data, which is I don't have the capacity to do this and nobody is paying me to do this. And I have 2 children at home and I have to teach them somehow during Corona, etc. Like I think we should build it into our workflows, but if you didn't, then it's a real burden to then make your data or your resources available. So yeah, I think we have to kind of provide people the capacity and then the reward structure to make this a part of our job. And it could take many forms, many different forms.
So another comment on the chat about being a responsibility of the journal publisher, but the consequence of no clear mandate is no compliance. Yeah, so it is a shared responsibility, actually, and we talk about that open data or fair data, or these things are shared responsibilities.
But New England Journal, for instance, had a literal mandate for sharing data. They say you must share data, and then people ask for the data and nothing happens. So even when there is a clear mandate, there is no enforcement mechanism other than kind of shame or something, which doesn't work and is not the most constructive and conducive way to do that. So yeah, it's not that easy a solution. But we've tried to share our aging data set in Cambridge with 800 people neuroimaging data. And we've shared it with 1,200 groups across the world now, which is very exciting, but it essentially costs a full-time postdoc to make that happen, which we were lucky enough to be able to cost. But it's essentially a postdoc that is spending a good chunk of their time because we value being able to share the data, which doesn't really have a clear benefit for kind of us other than this intrinsic thing that we think it's valuable to do. And it's a sufficiently large data set that lots of groups across the world might not be able to collect it. So we should share it. But you can't ask people to say, well, I have money for one postdoc and they shall spend their time making my resources freely available, because for lots of people that might literally mean I won't have a job in a few years. So, which is why I think your initiative is such a good one.
Yeah, thank you. And I suppose we're going to change topic a little bit because of the questions in the chat, but I suppose the message is perhaps that we as funders also have to do a better job at rewarding and maybe enforcing compliance. But the next question, well, is for you again on can you share a bit of your experiences publishing on the Welcome Open Research platform?
For us, it worked really well. I mean, our preprint was on PeerJ, where it was read 20, 30,000 times. I think it was in the top 10 most read papers, but they decided, well, it doesn't fit in one of our 32 topics, so you can't publish with us. So we had to not submit it there. And luckily the Welcome was not that precious about, yes, this is a slightly odd paper, but who cares? People will use it. So for us, that worked well. We didn't share the code within the paper. We just pointed to our GitHub repository and our notebook, and that seemed to work fine. Ideally, there are journals that actually do computational reproducibility. So in other words, if you submit a paper, someone at the journal has to try to reproduce your analyses, which I think would be a very good way to level the playing field and just kind of up the bar. I try to always assume that people will try to reproduce our analyses, and that's a really good way to find whether your pipeline has any errors in it. But I think at the journal level would be a good moment to have one person who tries to recreate your numbers. In general, good is the shorter answer to Hans.
Just to sort of add on to that a bit, I mean, for the heritage context on our 3D models, it's very difficult to publish those models in a traditional academic way with all of the metadata and the paradata and our interpretations. I mean, it's just currently not a standardized part of academic publishing in the heritage sector. So when we take these things online, we're still looking for that next level of usability and interactivity with those data sets, which is something that both the 4D Research Lab and my project had in common, that we really found that to be lacking. And there's another NVO project at the minute, Pure 3D, which is looking into creating these, a sort of standardized infrastructure for how you bring these 3D data sets to a wider audience, and how they can help build up a more permanent infrastructure for people with different size data sets to be able to bring them all together in the same way. So that's also a really worthwhile initiative, which is kind of just finding its feet and getting going. But the NVO is also supporting that at the University of Maastricht. So that's a great thing. So yeah.
Yeah, it feels we are almost close to the end. It feels like we could start another discussion on publishing, right? Because actually that struck me, especially because, when I was reading scientific papers every day, the first thing as a specialist you look at is the figures, right? You open a paper and you look at the figures is the first thing you want to see. And we were just seeing, well, in your case, Jill, how just a flat figure is not, it's not going to help you. And you're saying, Hertje, that many figures are actually very poor quality, but you know, papers are published, you know, with they don't seem, with figures that are not useful or are just bad. So it feels that we could open a new discussion on the innovation in publishing. I mean, maybe it's just, we have only 5 minutes. Do you want to reflect on this? I
mean, I don't think it's ever really taught. I mean, and I think it would be a really nice module in a larger, like how to publish. Sometimes we're taught how to write and maybe, if you're lucky, how to present, but why bother with data visualization? I mean, I saw one plot in a paper that had 100 people and they chopped them up into older than 50 and younger than 50. And then they did a scatter plot of the two groups and they showed the two groups differed in age. I mean, it's just like, why spend a figure on that? But I mean, I had the benefit of being taught by someone who we sat down and we literally discussed every figure in the papers, like what's the best figure here, and spent literally hours faffing about with the details, because over time you learn that one nice figure that is clear, not just like attractive, but also conveys the message that makes people guess what to look at and makes people look at what's important can do really well. And I worked as an RA on a project on PowerPoint, and there was about 120 rules that we decided on based on cognitive psychology that are essentially things you can do wrong, that it's not a matter of debate. Like if your font size is 3, then it's too small. It's not like, there's never a good case for it. So I had to go through 300 PowerPoints twice with 120 rules, and I'll leave the computation to you to count what was wrong. And if you do that once, then that's a bracing experience that makes you realize good and bad figures in presentation. So, but yeah, I think it should be part of, you can teach a lot in an hour or 2 or 3. So I think that should be more part of our formal academic education.
Any comments, Jill, or time? Yeah, I get the feeling that, you know, publications are the way they are because of a long tradition that goes back a few centuries behind, when maybe a paper now could be much more visual, right? For some results, maybe it's not like a written story, is actually the visual and being able to play with the data. And
yes, but also the size of 3D models and 3D data sets. So looking for long-term sustainable storage for those models is an issue. I mean, we were really happy to be able to work with this Figshare for using long-term sustainable storage that's already there as a sort of infrastructure. And we do need to keep an eye on how much data we generate and where it goes and how we store it. So we may hit a scaling up issue if we are wildly successful, you know, fingers crossed. But for now, it's manageable. But it is something that you have to always keep an eye on and plan ahead for. So yeah, it's not an easy thing. For archaeological journals, if you say I want to publish 25 3D models, I mean, there really are so few options about how you bring that data set to an explicitly archaeological or heritage publication. So yeah, it's still very, very tricky. It's not changing very quickly.
Thank you. I just want to, we have 2 minutes left actually, and I just want to check that whether there are any final questions from the, does anybody in the audience has any questions, final remarks they'd like to add? Because otherwise I think I'll start data visualization best practices.
Yeah, the fact you noted that there's lots of really good resources out there. So it's not that there's nothing out there to teach people to make nice figures. It's a mismatch between education and taking it seriously. Like, journals will rewrite your papers, but they'll never say figure 2 is a mess. I mean, which arguably they should.
Yeah, exactly. Yeah, even though, you know, also editors will look first at the figures themselves. I think we will close the session. I think maybe for many people, this is their last day of work before a long weekend. I'd like to thank you, Jill, Time, Rogier, very, very much for two very, very fascinating talks. Thank you so much for your talks. Thank you to the audience for attending. Thank you, everyone. We'll close the session now. Fantastic presentations indeed.
Thanks for coming, everyone.